Welcome to Physics and Rapid YouTube channel. In today's video, I'm going to deal with Cartesian, that is coordinate system. In the coordinate system, we have a Cartesian or the rectangular coordinate system, spherical coordinate system, and the cylindrical coordinate system. What does this table means? This table contains UA cap, U2 cap, and U3 cap. What are this U1, U2, and U3 are the unit vectors. H1, H2, H3 are the multipliers. DL is the length element, DS is the surface element, and dV is the volume element. So, what is the need of this table? Uh, the need of this table is to give a general formula for gradient, divergence, curl, and Laplacian. In the last video, I have told you about the gradient, divergence, and curl only in terms of Cartesian coordinates, and we have solved a few problems, right? In today's video, I'm going to write the same gradient, curl, and divergence in terms of a Cartesian, spherical, and cylindrical coordinate system generally. Using this formula, we can solve any problem. Any problem in the sense the problem is given in terms of a spherical coordinates, we can solve. The problem is given in terms of a cylindrical coordinates, we can solve. So let us start with today's video. So what is this U1 cap, U2 cap, U3 cap? I have already told. This is the unit vectors. In the Cartesian system, the unit vectors are x, y, and z. In the spherical system, the unit vectors are r, theta, and phi. Write in terms of a cap so that it is easily understandable. It is r cap, theta cap, and phi cap. In the cylindrical coordinate system, it is r cap, phi cap, and z cap. Right. Now, h1, h2, h3 are the multipliers. For Cartesian coordinate system, it will be 1, 1, 1. For the spherical coordinate system, it will be 1, r, and r sine theta. Okay. And for the cylindrical coordinate system, it is 1, r, and 1 again. So these are the multipliers, and dl, as I told earlier, this is the length element. So the length element for the Cartesian system can be dx, or it can be dy, or it can be dz. Okay, all three are used. For the spherical coordinate system, the length element is nothing but r into d theta. For the cylindrical system, the length element is r into d phi. Okay, now coming to the surface or the area element. So the area element in terms of a Cartesian, you can write it as dx dy or dy into dz or dz into dx. You can write in terms of three ways also. Whereas in spherical coordinate system, it is r square sine theta d theta into d phi. Okay. Now in the cylindrical system, it is r d phi into dz. Right. Now coming to the volume element. In volume element in the Cartesian coordinates, it is dx, dy, and dz. dx, dy, and dz. It is a volume element. Now coming to the spherical, it is very easy, r square sine theta dr d theta and d phi. Whereas coming to the cylindrical coordinates, it is r dr d phi and dz. You need to be careful. In the cylindrical coordinates, it will be phi and z cap, or r cap and phi cap z, or the unit vectors. The equation, whatever the equation they will be given, it will be in terms of r, phi, z only. Okay, I hope this table is very clear to everyone. Now, let us move to the next slide. In the next slide, what we have the general formula for the gradient. Yes, this is very important. So the general formula for the gradient can be written as 1 divided by h1 is the multiplier, dou divided by dou u1 into u1 cap, plus 1 divided by h2, dou divided by dou u2 into u2 cap plus 1 divided by h3 dou divided by dou u3 into u3 cap. Okay, this is a general formula. We can apply this formula for all three coordinate system. It can be Cartesian, it can be spherical, it can be cylindrical. So let us apply for uh, rectangular or the cylindrical rectangular or the Cartesian coordinates. So instead of h1 it is 1, instead of h2 it is 1, instead of h3 it is 1. Now instead of u1 it is x, u1 cap is x cap. So dou divided by dou x into x cap plus dou divided by dou y into y cap plus dou divided by dou z into z cap. So you can, the same way you can substitute for spherical and the cylindrical coordinates. Now let us move on to the next formula, that is a divergence of any vector that I'm considering as a vector. So a vector can be written as ax into I cap, ay into j cap, az into k cap in terms of Cartesian. Right, here I am writing as a1, a2, a3. Means this is a general formula, not only for doing for Cartesian. So in general, I can write it as a1, a2, a3. Yes, so the general formula for this divergence is 1 divided by h1, h2, h3 into dou divided by dou u1 into h2 h3 a1, right, like that only, plus dou divided by dou u2 h3 h1 into a2 plus dou divided by dou u3 h1 h2 into a3. So this is the general formula for the divergence of any vector, that is a vector. Let us move on to the curl of a vector, the general formula. It is again 1 divided by h1, h2, h3, determinant of h1 into u1 cap, h2 into u2 cap, h3 into u3 cap. Okay, below that it will be dou divided by dou u1, dou divided by dou u2, dou divided by dou u3. Below that it will be again h1, a1, h2, a2, h3, a3. So this is a general formula for curl of any vector I am considering as some a vector. Now what is this Laplacian? A Laplacian is nothing but the divergence of gradient. If we do the divergence of gradient, we get the Laplacian. Laplacian is represented by del square or the gradient square. Okay, so like this is a symbol del square, and phi is a any scalar you can consider. Okay, the formula for this is little bit complicated, but it is easy if you memorize. It will be h1 h2 h3 into dou divided by dou u1 of h2 h3 divided by h1 into dou divided by dou u1 phi 1. I can take, or you can take it as a phi, because phi 1 we will not take. Phi is a scalar. Scalar means completely you need to take. Okay, plus similarly you can do the rest. Dou divided by dou u2 h3 h1 divided by h2 into dou phi divided by dou u2, right. Last term is plus dou divided by dou u3 h1 h2 divided by h3 into dou phi divided by dou u3. So these are the general formulas for Laplacian. This is for the gradient, and this is for the divergence, and this is a curl. It is very easy. Once you look at it, you can grab easily. Now let us solve a few problems related to this formula one by one. Now the problems they have given here: calculate divergence of a vector which is equal to k into r sine theta into phi cap, where r, phi, z I think here they have missed here r, theta and phi. It should be r, theta and phi, or in terms of a spherical coordinates. Okay. Yes. Let us solve the problem. The solution for this problem is, we need to write the general formula for this divergence. So that general formula for this divergence is divergence of, once again, so divergence of a vector which is equal to 1 divided by h1, h2, h3 into dou divided by dou u1 into h2, h3 ax plus dou divided by dou u2 into h3, h1 ay plus dou divided by dou u3 into h1, h2 into az. So this is the general formula for the divergence, right? Now, instead of h1, h2, h3, they have clearly mentioned here spherical coordinates. Spherical coordinates h1, h2, h3 is, it will be r into r sine theta, 1 divided by r square sine theta. Now, carefully observe the question. They have given only the phi cap. Phi cap in the sense, instead of here ax, here it should be ar, here it should be a theta, and here it should be a phi. Okay. So I am writing in terms of a Cartesian. Here it should be ax, a theta, and a phi. Let me erase and write it properly, the formula, or you can write it as a1, a2, and a3. That is also fine. I will write it as a1, here a2, and here a3. Okay. Now, if you observe a1, they have not given the a1 term, a2 term also not given, a3 term they have given. So I can write it as dou divided by dou u3 in the sense, here it is r, theta and phi, means you are differentiating with respect to phi. You need to remember like that. Now h1, h2, h1 is 1, h2 is r, so it will be r, and a3 value is k into r into sine theta. Okay. Now see, here it is, they have given a very easy formula. It is dou phi. Dou phi, we are going to differentiate with respect to phi. Inside the bracket, we have only the terms containing r and theta. So r and theta will be constant. Obviously, this term will be 0. It will be 1 divided by r square sine theta into 0. So the answer will be again 0. Okay, I hope everyone is clear. So this is the importance of those formulas. They have asked the question in any coordinate system they can ask. So you need to know this formula and apply the formula and get the answer. Okay. Yes. Let us move on to the next question. The next question is, calculate Laplacian of del square of A. They have given A to be equal to K into R cube. Let us take this formula in spherical coordinates only. So the formula for Laplacian in spherical coordinates is del square of any scalar which is equal to 1 divided by h1, h2 and h3, right, into dou divided by dou u1, h2, h3 divided by h1 into dou a divided by dou u1, right. This is the general formula, plus dou divided by dou u2 into h3, h1 divided by h2 into dou a divided by dou u2, right. Next, plus similarly dou divided by dou u3, h1, h2 divided by h3 into dou a divided by dou u3. So this is the general formula to find the Laplacian, that is the del square of any scalar. Okay. So here if you observe clearly, it only depending on the r. So only first term will be used. Rest of the terms we will get the answer to be 0. So 1 divided by h1, h2, h3. So in the spherical coordinates, it will be r square sine theta into dou divided by dou u1. So dou divided by dou u1 is r, right? h2 into h3 divided by h1. h2 into h3 is r square sine theta divided by h1 is 1 into dou divided by dou u1. Instead of u1 is r. Instead of a, we have a k times of r cube. Okay. Now what you need to do, first differentiate this term completely, then after that the remaining terms you can again differentiate. Laplacian is nothing but 2 times differentiating partially. So r square sine theta dou divided by dou r we shall keep as it is, r square sine theta also as it is. K is constant, we will take out from the differentiation. Instead of differentiating r cube, it will be 3 times of r square, right? Now same as it is, carry forward, divided by dou divided by dou r, and k is constant, I can take out from the differentiation. Instead of and sine theta is also constant, you can take out. Let me write properly so that you can understand. So what is remaining outside the bracket, it will be 1 divided by r square sine theta, and k is also constant here, and sine theta is also constant. We have a variable only r. So and 3 is also constant. 3 will also come outside. It will be only r to the power of 4. Right. Now differentiating, we get 3 times of k sine theta get cancels, divided by r square into 4 times of r cube. Right. This is the solution we got. R square and square will get cancelled. So 4 3s are 12. So 12 times of k into r is the final solution for the given question. I hope everyone is clear. Like that you can solve many questions, whatever may be the question. This is the method to solve. I hope you can solve easily. So let us solve this question. Calculate the curl of the following vector, that is a vector which is equal to k divided by r phi cap in terms of a cylindrical coordinates. So how to write curl of a vector? Curl of a vector is nothing but 1 divided by h1, h2, h3 into h1 u1 cap, h2 u2 cap, h3 u3 cap, right? Determinant of, so here it will be dou divided by dou u1, dou divided by dou u2, dou divided by dou u3. Below that it will be h1 into a1, h1 into a2, h2 into a2. Here it will be h3 into a3, right? So in the cylindrical coordinates we have 1, r and 1. So h1 into h2, h3, it will be 1 divided by r. Instead of h1 it is 1. Instead of u1 it is r cap. h2 is r into phi cap. Here it will be h3 is again 1 into z cap. Okay. Dou divided by dou r, dou divided by dou phi. Here it will be dou divided by dou z. Now instead of h1 it is 1, a1 is a1 terms they have not given here, r cap terms it will be 0, and a2 terms also not given, or a2 term it is given, it is phi cap, right? So it will be k divided by r phi cap. So it will be k divided by r here. Sorry, some error occurred. Let me erase properly so that it will be visible. Now yes, come back, it will be k divided by r into phi cap. h2 is r, right? R is h2, k divided by r, and h3 is 1, h3 they have not given. So how to solve determinant I have already taught many times. in my YouTube channel. You can go and refer. So it will be 1 divided by r. So cancelling these two terms, it will be 0. This will be 0 minus r into phi cap. Cancelling first row and the second column, it will be 0. Remaining is only the z cap. So z cap into first differentiation of this constant, again it will be 0 0 completely. We are getting the answer to be 0. So this is the answer for the given vector, that is a vector, which is equal to k divided by r phi cap. So k divided by r phi cap, the Laplacian of this is 0. So I hope everyone is clear with today's video. Laplacian, it is a curl. Laplacian, they have asked the curl, right? It is a curl of the following vector, that is a vector, which is equal to kr divided by k divided by r phi cap, it is 0. So I hope everyone is clear with today's theory part and today's general formula for all gradient, divergence, and curl Laplacian. I introduced the Laplacian, which is also very important from the point of examination. And the three set of problems we have to find the curl, to find the Laplacian, and to find the divergence in all the coordinate systems. I hope everyone is clear. Thank you for watching. For more videos, you can visit my YouTube channel.